Imagine embarking on a long journey, far from any gas station or charging port. 4-hour intrepid spacecraft exploring the cosmos, reliable energy is not just convenient, it is absolutely essential. So, how do spaceship power systems work? At their core, spacecraft power systems primarily relying on one of two methods: harnessing solar energy through photovoltaic panels or generating electricity from radioactive decay using radioisotope thermoelectric generators. The choice between solar power and radioisotope power largely depends on a mission's distance from the sun and its expected duration. Solar panels work by converting sunlight directly into electricity, much like those you might see on rooftops here on Earth. This is highly efficient and sustainable for missions within the inner solar system, where sunlight is abundant and strong. However, for journeys far into the outer solar system, where sunlight is incredibly dim, or for probes that need to operate in constant shadow, solar power becomes impractical. That is where radioisotope thermoelectric generators, or RTGs, come in. These clever devices convert the heat naturally produced by the decay of radioactive material, typically plutonium-238, into electrical power. Understanding this fundamental difference helps explain why, for example, the International Space Station is covered in vast solar arrays, while distant explorers like the Voyager probes, the Curiosity rover on Mars, and the New Horizons spacecraft sailing past Pluto all use RTGs. Solar panels are simpler, lighter, and more widely available, making them a go-to for Earth-orbiting satellites and missions to inner planets. RTGs, on the other hand, offer a consistent and long-lasting power source independent of solar intensity, but they are more complex, heavier, and involve handling radioactive materials. An interesting detail is that even solar-powered spacecraft often include batteries. These are not for primary power, but for crucial energy storage, allowing the spacecraft to operate when it passes into the shadow of a planet or during periods of high power demand. Think of them as backup generators or power banks, ensuring continuous operation even when the main solar input is temporarily unavailable. These batteries are often advanced lithium-ion types, designed for the extreme conditions of space. Ultimately, the brilliant engineering behind these power systems is what enables humanity to venture farther and gather more knowledge about our universe. From the elegant simplicity of solar arrays to the robust reliability of radioisotope generators, each system is a testament to our ingenuity, providing the vital spark that illuminates our path through the stars and allows us to send back amazing discoveries for decades.
Join us at Space Tech Insider, where innovation meets the infinite. Discover the future today.